Let's look at another example. We're going to use Riemann sums to find the area of the region bound by the function f of x equals 2 minus 3x squared on the interval from 0 to 1. Again, we're going to try to fit an infinite number of rectangles within the width between 0 and 1. So if we're taking an interval of length 1 and dividing it into n pieces, the width of each rectangle is just going to be 1 over n. And as we add up the heights of these rectangles, again, the heights will depend on the function. In this case, it'll be the function at 1 over n times k, or just k over n. Remember, k is running from 1 to n. And again, we want to take the limit as n goes to infinity. So since our function is the function 2 minus 3x squared, f of k over n is 2 minus 3 times k over n, quantity squared. We're going to sum that. And again, pull out down our width and the limit. Okay, so this is going to equal the limit as n goes to infinity of 1 over n. And I'm going to take advantage of the properties of our sigma and rewrite this as the sum from k equals 1 to n of 2 minus the sum from k equals 1 to n of 3 times k over n squared. Okay, so we have, again, some more properties of sigma that we can use. Now, if I add up 2 n many times, I have this constant value rule. If I add up 2 plus 2 plus 2 plus 2 n many times, I'm going to get 2n. And over here, I can factor out the constants, which the coefficients, which in this case would be 3, and in the denominator, n squared. So I have 3 over n squared times the sum from k equals 1 to n of k squared. And let me just give myself a little bit more space. So this is going to be the limit as n goes to infinity of 1 over n times 2n minus 3 over n squared. And I'm going to use the formula for the sum of the first n perfect squares. So that's going to give me the n times n plus 1 times 2n plus 1 all over 6. Next, I'm going to distribute my 1 over n. So I get the limit as n goes to infinity of the n's are going to cancel in this first term because I've got 2n over n, so that's 2, minus over here 3n times n plus 1 times 2n plus 1 all over n times n squared times 6 is 6n cubed. Now, the limit as n goes to infinity of 2 is obviously just going to stay 2. The limit of this expression here, this is a rational expression where the numerator is a third degree polynomial. You can see this by foiling out this or distributing out this expression. So we'd get 3n times 2n would be the leading term. So 6n cubed would be my leading term. And in the denominator, my leading term is 6n cubed. So the ratio of the leading terms is 6 over 6 or 1. So I'm going to be subtracting 6 over 6 or 1. So the area is 2 minus 1 or 1.